All right, let's take a look at number 15. So suppose we want to test the effectiveness of a fertilizer on the weights of 12 poplar trees, and we have two plots of land. Plot A is dry while plot B is moist. Use a block design and randomly assign trees to treatments to diagram this experiment. All right, so our subjects are the 12 trees. And our blocks are going to be this plot A and plot B. And our factors and levels. So they don't really spell this out super clearly in here. So let's, our factor is going to be this fertilizer that we're testing. And we're going to just do two levels. So either no fertilizer or yes fertilizer. And then our response variable, we're testing the effectiveness on the weights of the trees. So the tree weight will be our response variable. And then it says blinding. Is this not blind, single blind, or double blind? So in this case, there's no placebo. We do have a control group, but no placebo. So we'd call this as not blind. And that's pretty typical if you are doing an experiment that is related to inanimate objects. Generally, we're looking at blinding when it comes to experiments that deal with people. All right, so let's diagram this. So our categories are our subjects, and then if there's an organizational component like these blocks or matched pairs, where they randomly assign to the groups, so how many people or objects are in each group, the treatment, and then the response variable. So we'll start with our 12 trees as our subjects. We're going to split those into two blocks. So we have plot A with 6 trees and plot B with 6 trees. And then we're going to split these into two groups of 3. So I have 3 trees, each one of these. And they weren't randomly assigned, so we'll skip that, or at least it doesn't say here. So what I will do is put a little asterisk down here and say RA not noted or not stated, something like that. Okay, one group will get fertilizer, one group gets no fertilizer. And then same for plot B. These two groups of 3 trees, one group will get fertilizer, the other gets no fertilizer. And then we're going to compare the tree weight within each block first. Okay, so we'll see if the dry plot works better with the fertilizer or the moist plot works better with the fertilizer, or maybe no fertilizer at all is the best. And then once we've compared within each block, then we do compare overall. So we'll compare the weight overall across the board. All right, so that gives us our 12 poplar trees. So let's take a look at the one below this. This one is really fascinating to me. It says, can chest pain be relieved by drilling holes in the heart? For more than a decade, surgeons have been using a laser procedure to drill holes in the heart. Many patients report a lasting and dramatic decrease in chest pain symptoms. Is the relief due to the procedure, or is it a placebo effect? A group of 298 volunteers, 100 women and 198 men, with severe untreatable chest pain were randomly assigned to get the laser or not. The patients were sedated but were awake. They could hear the doctors discuss the laser process. Each patient thought that he or she was receiving the treatment. The laser patients did well, but here's the surprise. The placebo group showed more improvement in pain relief. Okay, so this is why it's really important to include a placebo or have some form of blinding when you are working with humans, because this is really surprising that the placebo actually gave people more relief. That's quite interesting. All right, so let's see what pieces we have here. So our subjects are these 298 volunteers, 298 people. And then our blocks, they gave us that there were 100 women and 198 men. So we're going to make those our blocks. So men versus women. Our factor is the laser. That's the treatment people are getting. And either yes, they got it, or no, they didn't. And then our response variable is going to be our pain relief or pain levels, kind of depending on how you want to word that. And then is the experiment blind? So this experiment is definitely single blind since we have a placebo process here. It's potentially double blind, although I would be highly suspicious of that, just because the doctors do know who they actually use the real laser on and who they were just talking about using the laser. So I will call this one single blind. And then let's go ahead and diagram this. So our subjects are the 298 people. And then we're going to split those into two groups. So the problem tells us that there are 100 women and 98 men. So if they didn't tell us that, but we knew that we were supposed to be doing blocks, we would just split it evenly. If we actually know how many are in each group, then that's how many we would assign. All right, so we have the 100 women and the 98 or 198 men. Whoops. Let's fix that. And then we need to split these guys into groups. So we have two treatments, either yes laser or the placebo laser. So we'll have 50 women in each group. And then for the men, it looks like I'm going to have 99 men in each group. Okay, so I just took this number and divided it by 2. All right, and do they tell us that this is randomly assigned? Let's see. Yep, it does. It says randomly assigned, so let's put an RA in here. And then these ones got the laser, placebo, laser, and placebo. And we're going to compare the pain relief for the women. And then we'll compare the pain relief for the men. Right, so you always compare within each block, and then we'll compare the pain relief overall. All right, so there are 2 more block designs. Hopefully you're starting to get the hang of this.